Hey, this is Mr. D. I had to go to a meeting, so I made this video for y'all, so pay attention. This is what we talked about on Thursday and Friday. We talked about a ratio, and that was a comparison of two things. Just like we said, when I compare boys to girls, that's a ratio. That's the same thing as writing boys divided by girls. Okay? That's what we talked about on Thursday. And then when I have a proportion is when I have two ratios that are congruent. This means congruent. So let's say like we said that there were 7 boys and 14 girls. When I reduce that, that becomes 1/2. So see how this fraction is equal to this fraction? That's called a proportion. And then sometimes on your worksheet, instead of a 2 there, they have an x, and they're like, find x. Well, here, whenever that happens, I have to find the cross product. I have to cross multiply. So I would do 7 times x goes this way, and 14 times 1. So 14 equals 7x, and then I divide both sides by 7. So x is 2. That's what we talked about on Thursday and Friday. I'm going to clear something up because some of you are still confused. When I had a triangle, it looks like this, and this was a 3, and this was a 6, and I asked you 3 times a number gives me 6, and all of you could say 3 times 2 gives me 6. So when they ask you for the scale factor, you would have said 2. And then you saw this and you got all confused. You saw, instead of a 3 and a 6, you saw maybe a 3 and a 4. And you said, well, Mr. D, 3 times a number does not give me 4. 3 times a number does not give me 4. This is an algebra problem. Here's a trick. I take something new over something old, and that will give me my scale factor. So something new is 4, something old is 3, so my scale factor is 4/3. So try to remember this: new over old, new over old, new over old, new over old. Okay? Now, let's move on. Last semester we talked about congruent triangles. We said in order for two triangles to be congruent, I have to use these theorems: SSS, SAS, ASA, AAS. Here, I have two triangles. I need to figure out if they are congruent, and I need to see which theorem it is. Well, they give me an A here, and an S, and an A. So that looks like that one. So yes, these two triangles are congruent because I have an angle that's congruent to this angle. This side is congruent to this side. This angle is congruent to this angle. So that's A, S, A. And here I have an angle, I have a side, I have this angle, I have this side. I have this angle right here that's congruent to this because they're vertical. So they are congruent by this theorem. That's what we did last semester. So today we're going to do basically the exact same thing, but instead of using the word congruent, we're going to use the word similar. You have to know the difference between similar and congruent. The congruent symbol looks like this. The similar symbol looks like this. The congruent says they are the same size, same shape. If they're similar, that means they are proportional. or dilated. So in your chart you see this angle similarity. Angle similarity. The symbol for that is this AA similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. See how this, let's put some numbers in there. If this is a 40, this is congruent to this, which is 40. And if this is 120, then this over here has to be 120. So I have two angles that are congruent, which means that's enough to tell me they are similar. I have side angle side similarity, so it looks like this, and it says if an angle of one triangle is congruent to an angle of a second, and the sides of two angles are proportional, then the angles are similar. Proportional. I have a 3 here, I compare that to 6. I have a 2 here, I compare that to 4, and this angle is congruent to this. I have a 3, I compare it to the 6. I have a 4, I compare it to the 8. 3 over 6 should reduce to 1/2. 4 over 8 should reduce to 1/2. These two things are the same, so they are proportional. I have two proportional sides, one included angle. I have SAS. Side-side similarity says I have SSS. If the corresponding sides of two triangles are proportional, then the triangles are similar. Again, proportional means I compare 6 to 3, I compare 8 to 4, and I compare 10 to 5. If these fractions are all the same, they are proportional. Now, let's try it. This is number 1 on your classwork. It says, I'm given this isosceles triangle and this triangle with two angles. So if I know this is an isosceles, then this one has to be 50. What's 50 plus 50? 100. So that means this side should be 180 minus 100, and that gives me 80. Here, 30 plus 50. 30 plus 50 is 80, so this side has to be 180. What? It has to be 180 minus 80 gives me 100. So this one right here has to be 100. Well, there's only one theorem that I could possibly use that looks like this, but I don't have two angles congruent. I just have one. So I can't use this. Therefore, they are not congruent or similar. They are not similar. Let's try this one. 3 S's. Let's make sure that I can use this. I want to see if I can use this. So I'm going to compare 15 to 5. And I'm going to compare 12 and 4 and 9 and 3.5. 15 over 5 is 3. 12 over 4 is 3. 9 over 3.5 is not 3. So I should have had 3 sides proportional, but I don't. So this is not proven to be similar. Let's try this one. I want you to see that this has inches and this has feet. This has feet, this has feet. So I'm going to change everything to feet first. 96 inches. Well, I know that 1 foot is 12 inches. So 96 divided by 12 gives me 8 feet. 72 inches divided by 12 gives me 6 feet. That's it. Oh, 60 divided by 12 is 5 feet. Okay, here's what I want you to see. I want you to see this big triangle. Looks like this. See how there's a 6 feet here and 8 feet here, and this long side right here. 6 plus 4 is 10. Then I want you to look at this little triangle. It looks like this. So this is a 3, this is a 4, and this is a 5. Now I want to start comparing things. I'm going to compare 3 to 6, 4 to 8, and 5 to 10. Are they all the same fraction when I reduce them? Yes. So they are similar by the SSS theorem. Okay? Go ahead and start working on your worksheet. Work on that. Okay, thanks.